Hey everyone, today we'll be going over the blind 75 in TypeScript, and today we're focusing on the problem toSum. Now, given an array of integers, nums, and integer target, return indices of the two numbers such they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So, before we get started, make sure we always have our 4 questions we need to ask. We first need to ask ourselves, what is the input? What data structure / algorithm to use? What are we going to do with the data? And finally, what our output is going to be. So, be able to break down exactly what we are looking for. We can see in the example we have an array of nums already set in place, and also given the parameters that we already have, we have an array of numbers, and we have a given target number that we're looking for. So that will be our input. So we would have an array of numbers indicated as number over here, and we have a target which will be indicated as an integer we are looking for in the array of numbers. If we can see in our example, we have an array of numbers 2, 7, 11, 15, and target 9, and our output is 0 and 1. We're really returning the indices that we are looking for, since arrays typically start with 0. Here, when we search throughout the rest of the array, we see that indice 0 at 2 and indice 1 at 7 add up to 9 altogether. So we return the indices 0 and 1. So, as a bit of a star note, arrays always start with 0, 1, 2. Indices always start with 0, 1, 2, etc. And now the data structure / algorithm we're going to be using is that we will be using a hash map, where in TypeScript the way it's already typed out is that it's going to be map number number. Since hash maps typically have a key value pair associated with it, so we do this for constant time lookups, and we can imagine a hash map like an array of lockers, and then we have a key that we open a specific locker to. And hash maps are very useful for what we implement in. And what we do is that we store each number with its index as we iterate throughout the array. And what are we going to do with the data? It's simple. We're going to be looping through the nums array. And for each number, we're going to compute the complement. Since we already know that we already figured out what target is, since we're going to be given it, we're also going to subtract it with our current number, which will be inside the array. And then we're going to check if the complement exists in the map. If yes, we're going to return the index of the complement, which will be the current index per se, if it already matches up with the target. And then if no, we're going to store the current number and its index in the map, stating, hey, we have already seen this, since we need to output what adds up to the target, which is what we are returning. So what we're returning is that we need to return an array of indices which add up to the target. So it could be I and j. We can represent them as variables such that nums of I plus nums of j will, hang on, give me a second, will equal the target, like the actual numbers itself. And we use nums of I and nums of j as variables that will add up to the target, since it will be a number that we have already set up in place. So the first thing we need to do is that we first need to initialize everything. So we have constant map, and number with equal new map already had over here, which stores the number we have seen with its given index. So we have a number and the number indicated for number per index. Let's see if I can just, like, there we go. That's better. All right. And then what we're going to be doing, since we are going to be looping through the nums array, is that I'm going to use a for loop. We're going to use for, and TypeScript, they use let I equals 0, and I is less than nums.length with I iterating up, and then we're going to have another constant that we're going to have as a complement. Well, the target, since it's inside of a parameter, we can just use it, minus the nums of I, since we already have an array of numbers already set up in place, and we've initialized our map, and we have nums.length simultaneously due to this over here. So this is why we're using this. And then we are going to be using the Boolean condition over here. If map, and TypeScript has, and then complement, we're going to return the map.get complement with this given index. And then we will use this map.set nums of I for its actual number with its relative index as well. Finally, we will be returning the given array we have. So this will be our edge case. We have nothing to return over here. And specifically, if we wanted to be able to break down what we have in place, this will store the current number and index. And this will be our output that we have, which will indicate if the complement exists, we're going to return its index and the current index. There we go. I'll just put it with it. There we go. So now I'm just going to run this and make sure it actually is good. If it passes all the test cases, we're running. And passes all the test cases. Now I'm going to submit it. And we are good. So overall, based on our following solution, is that the time complexity for our given program is that it's going to be O of n along with the space complexity O of n, because n represents the size of a given array that we would have. And since we are storing the index and the number that we have seen using a hash map, n is going to represent the size of the array, and as the complexity or the size of a given array increases, so will the time and the space complexity consistently be. And so yes, this was the Blind 75 in TypeScript, focusing on twosome for arrays. Thank you very much for taking time to watch this. If you found this video helpful, be sure to feel free to please like and subscribe. And if you have any other questions, please put them in the comment section. And as always, take care. Cheers. Bye-bye.